So good evening friends, welcome back to Adami Education. Today is the second live session from this channel and I hope you all are doing well in this cold. And before we start with the new topics today, we are going to solve the questions which I gave to you as homework yesterday, and thereafter we will move on to the next topics. So the first homework was that you had to find out the group number and the period number for the elements which had atomic numbers 4, 19 and 16. So let us quickly find out the answer. So for an atom with atomic number 4, the electronic configuration will be 2, 2, and for 19 it will be 2, 8, 8, 1, and for 16 it will be 2, 8, 6. So what do we see over here? For the first case, the number of valence electrons is 2. That means it belongs to group 2 or group 2A, right? Now for the next case, the valence electron is 1. That means it belongs to 1 or 1A. You can write either. And for the third one, it is 6. That means we can either write 6A or we can write 16. Now talking about the period number, the first element has 2 shells, so it belongs to the second period. The second element has 4 shells, that means it belongs to the fourth period. And the third element has 3 shells, so it belongs to the third period. So this is the answer of the first question. Now moving on to the next question which I gave as homework. This was the homework, question number 15. So name the type of elements which have their outermost shell complete. I told you yesterday that the 8th group element have an octet or a duplet and they are called noble gases. So the answer will be noble gas. Their outermost shell is completely filled. The next question is outermost shell is incomplete. That means outermost shell is not filled. They are the representative elements or the main group elements or the normal elements which we will study about. Next is 2 outermost shells incomplete. That means this is a very special type of element and they are called transition elements. We have studied about it yesterday. Next is 1 electron short of octet. That means there are 7 electrons. For becoming octet, they require 1 more electron. So which type of elements have 7 electrons in its outermost shell? They are called halogens. So the answer will be halogens or the group 17 elements. The last question is 2 electrons in the outermost orbit. We know if there are 2 electrons in the outermost shell or in the outermost orbit, they will belong to the second group, and the second group elements are known as alkaline earth metals. So the answer is alkaline earth metals. So these were the homework which I asked you to do yesterday, and these are the answers. Now we will move on to the next part of the chapter. Okay, we have another set of questions over here. So let's do it. It is a very good thing that we have some more questions today. So we have to correct the statements. Here we have 4 statements and we have to correct them. So let's see. Elements in the same period have the same valency, is it? It is not correct. So elements in the same group have the same valency because they have the same number of valence electrons. So the answer will be elements in the same group, not in the same period. Next is valency depends upon the number of shells in an atom. No, it is not correct. Valency depends upon the number of valence electrons. So the answer will be number of valence electrons. Valence electrons. The next question is copper and zinc are representative elements, but no, they do not belong to the main group elements. They are called transition elements. So the answer will not be representative, it will be transition. So copper and zinc are transition elements. They lie in the middle part of the periodic table, which you will learn in class 11 and 12. The fourth question is transition elements are placed at the extreme right of the periodic table. Is it so? We just saw here, right, that transition elements are present in the middle part. So which elements are present in the extreme right? Extreme right means 8 group element or the noble gases. So the answer will be noble gases or the 0 group elements. We can say either. So these are the questions, and now let's move on to the next part of the chapter. Yesterday we have seen what are periodic properties and what is periodicity. Let me just quickly recapitulate it. The properties of elements which gradually change but they also become equal to one another due to their electronic configuration or basically due to the number of valence electron. Those properties are known as periodic properties. And this phenomena of gradual change in the properties and also sometimes there is similarity in the properties, this type of phenomena is known as periodicity. We have learned it yesterday, and one more important thing which we are going to learn today is that as we move down the group, that means from top to bottom in a particular group, these periodic properties will show a variation. What type of variation we will learn. And also if we move from left to right in a period, in a single period, the elements in that period will also show a gradual variation in the properties. What type of change will occur or why the change will occur, we are going to learn about that also. So what are the periodic properties which we will learn in this chapter? First of all is the atomic size or the atomic radius, the size of the atom. That is a very important and the most essential periodic property which is helpful in understanding all the other periodic properties. Next is the metallic and the non-metallic character, very much interlinked and easy to remember also. And the last three are very, very essential. This will also help you to understand chapters in class 11 and 12. So you have to understand the last three quite well. So the first one is ionization potential or ionization energy. Next one is electron affinity, and the third one is electronegativity. Today we will just focus on atomic size and certain things related to atomic size. So what is atomic size? What do you mean by atomic size? Let's see. It is the distance between the center of the nucleus of an atom and its outermost shell. What does it mean? Let me make a diagram and help you out. So if I have an atom as such, so this is the nucleus, the black dot in the middle, and this is the outermost shell. So the distance between the nucleus and the outermost shell, this particular distance, this is known as the atomic size. It can also be denoted by small r. Also, this is in the case of an atom. What about in the case of a molecule? If we have a molecule which contains two atoms, as you can see, this is the distance between the two nucleus or between the two nuclei. This distance is also the atomic size. So for a molecule, it is the distance between the two nuclei or the internuclear distance. And for an atom, it is the distance between the nucleus and the outermost shell. So this is the definition of atomic size. It is a very, very small quantity. So it is generally measured by using units such as picometer or angstrom. Very, very small units. So depending upon the atomic size, we can say what type of changes occur in case of the same group when we move from top to bottom, and in case of the same period when we move from left to right. So let's see. So atomic size depends upon a number of things. First of all, it depends upon the number of shells of the atom, and it also depends upon the nuclear charge. So let's see the first case first. Number of shells. An increase in the number of shells increases the size of an atom because the distance between the outermost shell and the nucleus increases. So let me explain this to you using a very simple example. Let us consider three elements: lithium, sodium, and potassium. Let us quickly write the electronic configurations. So for lithium, first of all, it will be 2, 1. For sodium, it will be 2, 8, 1. And for potassium, it will be 2, 8, 8, 1. So let us make the structures, the orbital structures. I am not making the electrons because it is not essential. I am just making the number of shells. So as you can see, it is very clearly identifiable that more the number of shells, larger is the size of the atom. That means that the size of potassium is more than sodium, and gradually it is more than lithium. So more the number of shells, more is the size of the atom, or more is the atomic size. So number of the shell is directly proportional to the atomic size. So whenever the number of shells will increase, the distance between the outermost shell and the nucleus will increase. As a result, the atomic size will also increase. Now what is the nuclear charge? As the name suggests, it is the charge through which the nucleus will pull the electrons towards itself. Why? Because the electrons are negatively charged, and the nucleus is actually made up of protons and neutrons have no charge, you know about this. So the protons which are positively charged, they will attract the electrons towards itself. So this charge provided by the nucleus to the electrons, it is known as nuclear charge. So if the charge is more, that means if the nucleus is pulling the electrons towards itself, what will happen? The size of the atom will shrink and the size of the atom will be small. But if the nuclear pull is not very high, that means the nucleus is not pulling the electrons close to one another, close to it, what will happen? The electrons can easily move farther away, and hence the size of the atom will be larger. So more the nuclear charge, more is the smaller is the atom basically. more is the closeness of the electrons towards the nucleus. So if the nuclear charge is very high, the atom will be small, but if the nuclear charge is very small, the atom will be quite large. So in which case, out of the first three elements, lithium, sodium and potassium, which will have the highest nuclear charge? Obviously lithium, because its size is very small. And which will have the lowest nuclear charge? Obviously potassium in this case, because it has the largest size. So what is nuclear charge? Let the definition. It is the positive charge present in the nucleus of an atom. Positive, why? Because it is the charge exerted by the protons, which is equal to the number of protons in the nucleus, because it is the charge which is given by the proton itself. An increase in the nuclear charge decreases the size of the atom. So more the nuclear charge, more will be the electrons close to the nucleus and smaller will be the size. So more the nuclear charge, smaller is large. I'm very sorry. More the nuclear charge, the electrons will be very close and the size of the atom will be quite small. So these are the two concepts which you have to remember for understanding any periodic property. Size of the atom and the nuclear charge. Very, very important. So let's move on to the next topic. What happens to the atomic size when we move down a group or when we move across a period? Let's see. Down a group, what happens? Down a group, the size will increase due to the increase in the number of shells. Let us consider group 1 elements alongside. See, over here we have a table where all the group 1 elements have been written. You can skip hydrogen because although hydrogen belongs to group 1, it also shows properties similar to halogens. So hydrogen nowadays in the new periodic tables which you will see in the copies and in the various charts, hydrogen is not placed in group 1. Rather, it is placed at the topmost portion of the periodic table. So we can just skip hydrogen. Let us consider from lithium. So we have lithium, sodium, potassium, rubidium and cesium. All these are the elements of group 1. So what do you see? As we are moving down the group, we are moving down the group like this. Lithium is at the top of the group and then we move to sodium, potassium, rubidium and cesium. We are not considering francium here because francium is radioactive in nature and its properties are somewhat different. So we will just consider till cesium. So what do you see? Lithium had 2 shells, sodium had 3 shells, potassium had 4 shells, rubidium had 5 shells and cesium had 6 shells. And as a result, since the number of shells are increasing, the size is also increasing. So the lithium element has the smallest size and cesium has the largest size. So as we move down the group, the size of the atom will increase. Why? Because the shells are increasing. Like we just studied, more the number of shells, more is the size. So as we move down, the shells are increasing and hence the size is also increasing. Now what happens across a period? Let's see. Across a period, the atomic size will decrease as the nuclear charge will increase. Like I told you just earlier, that more the nuclear charge, smaller is the atom because more the pull of the protons towards the electrons. As a result, what happens? As we are moving across the period, the number of shells will remain same in a period. We have studied about it in the previous lecture, but the nuclear charge is so high that the atom gets shrinked. The atoms become small. You can see over here we are moving from left to right now. From lithium we are moving to fluorine. So lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. You can see that all of them have 2 shells. Each one of them has 2 shells. But what do you see? The size of fluorine is very small as compared to that of lithium. Because as we are moving from left to right in a period, the nuclear charge increases to a very high extent. And as a result, the size of the atom will also be small. So in case of a group, as we move down a group, the size of the atom will increase. But in case of a period, as we move from left to right, the size of the atom will decrease. Very important trends. These are the trends which will help you to understand the 3 important periodic properties, which are the electron affinity, electronegativity and ionization potential. Next, let's see one very interesting thing. Now you might think that if fluorine has a very small size, what comes right after fluorine? It is neon. That means neon must have a much smaller size. But no, my dear, it is completely different. Why? Because neon is a noble gas. So noble gases have some specific properties which makes it different from the other elements of the same period. So let's see what is that special difference. As an exception, the size of the atoms of inert gases or noble gases is bigger. Why does it happen? This is because the outer shell of inert gases is complete. It is octet. They have the maximum number of electrons in the outermost orbit, thus the electronic repulsions are maximum. Now you know one thing, that if you keep 2 electrons close to one another, they will repel one another, isn't it? You have seen this in case of the like poles of a magnet also. So if you keep two like charges close to one another, they will repel. So in case of a noble gas, what happens? As you can see in the outermost shell, there are 8 electrons. So 8 electrons together, they will start repelling each other. And as a result of this repulsion, they will move farther away from the nucleus. So their size is slightly larger than the other elements of the same period. The major reason is that their outermost shell is complete, and due to inter-electronic repulsions, they are not able to stay close to the nucleus. The nuclear pull is not able to pull it towards itself. The interelectronic repulsions are too much. As a result, they move farther away. Therefore, we can say that the size of an atom of an inert gas or of a noble gas is bigger. So, a very interesting question can be asked, that in case of fluorine and neon, which one will have a larger size and why? So if we follow the trend, fluorine is in the 7th group but neon is in the 8th group, but they belong to the same period. That means if we move from left to right in a period, this should have a larger size as compared to neon. But that doesn't happen because neon is a noble gas. So you have to explain, you have to tell about interelectronic repulsions, you have to say about the total number of electrons in the outermost shell of neon. So this is a very important question which can be asked in your board examinations. Now our next topic is related to cations, anions and isoelectronic species. A very important question, that which one is larger, sodium ion or sodium atom? Or if a question comes as such that chloride ion is larger or chlorine atom is larger, how will we answer this? So to answer these queries or to understand why does this question arise even, we will understand this through the topics which I have mentioned over here. So let's see. The cation is always larger than the parent atom, something which is very universally true. And the anion is always larger than the parent atom. So let's see why does it happen. What do you mean by cation? Cation means a positive ion and anion means a negative ion. And you know anions are actually formed by the non-metals and cations are formed by the metals. So why a cation is always smaller than the parent atom? Now what is a parent atom? It is the atom which will lose the electron to form a cation. So the main atom which was initially there, that is the parent. Okay, and the cation is the positively charged ion and the anion is the negatively charged ion. I hope it is clear till here. So a cation is formed by the loss of electrons. Hence protons are more than the electrons in a cation. Let us consider sodium over here. Sodium atom, it has an electronic configuration of 281, and when it becomes sodium ion it will become 2,8. So one thing we can very easily see that it has more number of shells as compared to this, so obviously sodium atom is larger, isn't it? Because sodium is the parent atom here and we know the parent atom is larger than the cation. But another important reason is that in case of sodium atom there are 11 electrons and 11 protons. So there is a balance between the electrons and the protons. The positive charge and the negative charge is equal. But what happens in case of sodium ion? There are 11 protons but there are only 10 electrons. So which has a higher ability over here? Obviously the protons. And the protons, due to its ability, due to its positive charge, it will pull the electrons towards itself, and as a result the atom will shrink, or the ion will shrink rather, that would be the correct term. The ion will shrink. So the size of the cation is becoming smaller than the parent atom. The first reason will definitely be, as soon as we see it, the number of shells. But if we want to go deep into it, we have to say that due to the extra number of protons, the nuclear charge is more and hence the atom will shrink. As a result, the size will decrease. So this is a very important result. Now let's talk about why an anion is larger than the parent atom. So what has been said, let's see. Anion is formed by the gain of electrons, obviously. But over here you can see in case of chlorine atom and chloride ion, they have the same number of shells. So how can we differentiate over here that which one is larger? In case of chlorine atom, what happens? How many protons are there and how many electrons are there? Let's see. There are 17 electrons and there are 17 protons initially in the parent atom. But when it gains one more electron, what happens? How many protons are there? Protons are not changing, they are remaining 17 itself, but the number of electrons are becoming 18. So in this case, which particle has the larger ability? Obviously the electron. the protons are less in number, so the positive charge of the nucleus or the nuclear charge is less. So what happens? The protons are not able to pull the electrons or to pull the shells towards itself. As a result, instead of shrinking, the atom becomes a little larger. First of all, due to inter-electronic repulsion also, because the outermost shell is complete now. We just saw in case of inert gases, whenever the outermost shell is complete, inter-electronic repulsions will occur. The electrons will start repelling one another. So that is one reason. Another reason is that the proton number is low now, so the protons will not able to exert the same amount of nuclear charge anymore. So instead of shrinkage, the atom will become a little larger. The size will not increase tenfold or twofold, it will just increase a little bit. So you can understand the difference. So an anion is always larger than the parent atom, but a cation will always be smaller than the parent atom. So if I ask you a question as such, let me just rub it once first. So out of magnesium atom and magnesium ion, which one will be larger? This is a cation. Cation is always smaller than the parent atom, so the magnesium atom will be larger than the magnesium ion. Now if I ask you another question, which one will be larger, fluorine ion or fluorine atom? Obviously fluorine ion will be larger because this is an anion. Ion will always be larger than the parent atom. So I hope this is clear till here. Our next and final topic for today is isoelectronic ions. What are isoelectronic ions? Let me tell you a very interesting thing which happened when we were in class 10 most probably. A question came in our exam that what is isoelectronic ion or what are isoelectronic species. We had no idea what it was. It was not taught to us in the class. This topic was not there in our book that time. So I was really blank. I did not know what to do. But then I just thought, how can I relate this to my common day-to-day life? So we know about isotope. We have studied about isotope earlier. So iso, the word means same. So I tried to think that isoelectronic, that means same number of electrons. That can be a possible thing. So I tried to find the number of electrons in each of the species, and lo and behold, I got my answer and I got the marks also. So that you don't face the issue, I am here to explain this to you too. So let's see what are isoelectronic ions or isoelectronic species. So isoelectronic species or isoelectronic ions are ions or maybe species or elements which have the same number of electrons. For example, just check over here: magnesium ion Mg2 plus, sodium ion, fluoride ion and oxide ion. So let's see what are the number of electrons in each of this. Magnesium ion has 10 electrons, sodium ion has 10 electrons, fluoride ion has 10 electrons and oxide ion also has 10 electrons. So all of these, although they are all different elements, but after forming ions they have the same number of electrons. So these are called isoelectronic species. So what has been said about this size? Let's see. Greater the nuclear charge, smaller is the size. So in this case, which ion has the highest nuclear charge? Obviously magnesium, because it has the same number of protons as it had before, but the number of electrons is 2 less. So proton has a very high hand out here. The proton has quite a good significant role here. So the nuclear charge is larger. In case of sodium C, Na+, that means one electron is being lost. Number of protons is remaining same, but the number of electrons is less by only one amount. So obviously the proton has a larger hand, but comparatively lesser as compared to magnesium. So magnesium is the smallest and then comes sodium. Now talking about fluorine and oxide ion, fluoride ion and oxide ion. Fluoride ion also has one electron extra. So obviously electrons have a higher hand over here. Protons are one less comparatively. So it is large, but not as large as the oxide ion, which has 2 electrons extra. So 2 protons are less. That means the nuclear charge is decreasing a little more. So the oxide ion has the largest size and magnesium ion has the smallest size. As you can see the size over here, you don't have to remember obviously, but still we can just check it out. The size of magnesium ion is 0.65, sodium ion it is 0.95, for fluoride ion it is 1.26 and for oxide ion it is 1.42. Like a huge difference, isn't it? So the oxide ion has the largest size, but the magnesium ion has the smallest size. So what is the summary of the entire thing? Greater the nuclear charge, more the amount of nuclear pull, smaller is the size of the atom or the ion over here also. So I hope it is clear till here. We have learned that the cation is always smaller than the parent atom, the anion is always larger than the parent atom, and For isoelectronic species, we have to check which has the higher nuclear charge, and that will be the smallest one. Now I have a question over here. We have to identify the isoelectronic species in this case. So let us quickly do it. So sodium ion Na plus, K plus, Mg2 plus, Ca2 plus, S2 minus, this is sulfur ion or sulfide ion, and argon. So we are going to write the electronic configurations and we will check. So sodium ion, sodium has 11 electrons in all, but one electron has been lost, so it will be 2, 8. That means 10 electrons. Potassium ion, potassium is 19. Now it has 18, 18 electrons. Yes. Magnesium 2 plus, magnesium has 12 electrons, but now 2 electrons have been removed, so it has 10 electrons. Yes, so we saw sodium and magnesium are isoelectronic species. Now let's check the other ones also. Calcium 2 plus, calcium has number of electrons, yes, 20. So now if 2 electrons are removed from 20, it will become 18. So yeah, we saw again potassium and calcium are isoelectronic species. These ions, not potassium and calcium, potassium ion and calcium ion, they are isoelectronic species. Sulfide ion, let's see. Sulfide, sulfur has 16, 2 electrons extra, 16, 17, 18. Yes, this is also an isoelectronic species along with calcium ion and potassium ion. Now talking about argon. Argon has 18 electrons in all. So yes, all the blue colored ones are isoelectronic species and all the purple colored ones are isoelectronic species. So these type of questions can also be asked in the board examination. Very simple, but you have to make sure that you're doing it correctly. So whatever we have learned today, that is the most important part of the periodic table, because on the basis of whatever we learned, all the other periodic properties will depend upon it. So we have studied about the atomic size and the nuclear charge. So all the other periodic properties like the metallic nature, the non-metallic nature, ionization potential, electron affinity, electronegativity, all of it will be based on these two parameters. So this is a very important lecture and I hope you have understood the lecture. Feel free to comment if you have any doubts in the comment section, and if you have any suggestions on how can I make the session much more better for you, you can also give your suggestions in the comment box. And also if you have any doubts, you can send an email to the mail provided in the description box. I hope I'll be able to solve your doubts, and let's meet very soon for the next session. Until then, keep studying, keep rocking. Bye bye.